very short video on what are called pseudo rate laws. It's a concept you need to be aware of, but they can't ask you any mathematical questions about per se. All right, so here's the situation. Let's say most of the integrated rate laws that you're going to see involve just one reactant, but the reality is most chemical reactions don't involve just one reactant. Okay, so how do they get around this to make the math easy for you? What they do is they create what's called a pseudo rate law. And they do this by a little trick. And the trick is very simple. All right, here's the trick. The trick is, if you, let's say you have a reaction like this, we have three reactions: bromate ion, okay, bromide ions, 5 of them, and 6 hydroniums or H pluses reacting to make 3 bromines and 3 waters. You have 3 reactants here, okay? Now, what you want to notice is the starting concentrations here. They start the concentration of the bromide ion at 1 molar and the hydronium at 1 molar, and they start the concentration of the bromate ion at 0.001. And they do the usual thing. They follow the concentration as time elapses. Now, notice I left the other ones out of the table, but I could put them in if I so desired. And the reason why I could do that without even thinking is this. There's the Br minus I'm putting in there. There's the H plus. I'll put it in there, right? They're starting at 1 and 1, 1.0, 1.0. Look at the sig figs here, okay? Essentially, from time 1 to time 2, okay, the concentration of the bromate ion went down by 0.0003. If you subtract 0.0003, even if you multiply it by 5, okay, that comes out to 0.0015. So this guy's going down by 0.0015. If you do sig figs, this rounds to the 10th place, doesn't it? You're still going to have 1.0. Now, that's not saying the bromide doesn't conceptually go down a little bit, but statistically, mathematically, it's insignificant. So here's the general idea. To create a pseudo rate law, you have 3 reactants, one of which you start at a very low concentration, the other 2 or 3 or whatever it is at very high concentrations. The ones at very high concentrations, while they're changed, will change so little that mathematically, okay, the change will be insignificant. So you can end up with a rate law where you go like the rate is equal to, equal to K times BrO3 to let's say the first power. It's first order with respect to that. And you really have no idea what it is with respect to these other two reactants because you didn't bother measuring how they change their concentration. And what this means is this rate law will be functional under any conditions in which the concentrations of the other 2 reactants are very, very high. And you know what it is with respect to this reaction, it's first order. You could conceivably do this for the other reactants as well and figure out what the rate laws are with respect to those by making the concentration of, let's say, the BrO3 minus very high in another trial and keeping the Br minus to be the one that's very, very low. This is called pseudo rate law because it leaves out the other reactants, the ones whose concentrations were higher. It's a concept question. You will not see math, but if they ever ask you how to do this experiment, you should know have one concentration low, have the other ones very high, so that they do not change significantly. Take the concentration that changes over time, see if it, and then graph it, or graph the natural log, or graph 1 over the concentration to see if it's 0th, 1st, or 2nd order.